Welcome back to our channel, that is Ajay Kumar Yadav, and we are going to talk about today, that is displacement time graph. So displacement time graph, as you know very well, that is the today's concept for the session. So in this displacement time graph, we are going to draw a graph and we are trying to summarize the things, how the displacement time graph will behave. If this is the displacement time graph, this is my x-axis, this is my y-axis, and this is my time section, and this is my displacement section. So if the straight line, the behavior of the slope, now I would like to know the displacement. Now I would like to know the curve slope of a displacement time graph. So what is the slope of displacement time graph? The displacement time graph slope will be always represented as a constant velocity. It is, first of all, it is a straight line. You have to represent that line. It is a straight line and the slope will be always constant velocity. It is always constant velocity. So constant velocity you have to represent for the displacement time graph. Same manner we can also say that velocity time graph. So how would you understand about the velocity time graph? So if you talk about the velocity time graph, you have to draw the graph in the same style and you have to represent it is my time section, it is my velocity section. So in this case, it is my x-axis, it is my y-axis. Suppose this is the slope of an velocity time graph. So what do you understand from the slope of velocity time graph? Slope of velocity time graph is slope of an velocity time graph. So how would you behave with the velocity time graph? First, it is a straight line. First, it is a straight line. The second thing we have to understand, it is a constant acceleration. It is called as the constant acceleration. Okay, so it is a constant acceleration. Next, we are going to talk about the curve graph. The very next concept is curve graph. Sir, how can we behave the behavior of an curve graph? We would like to know the behavior of an curve graph. Now we are going to talk about the next graphical section, that is curve graph. In this curve graph, we are going to talk about the displacement time graph. So same thing you have to consider, but in a different style. So here also we are going to talk about the x-axis with respect to the y-axis. So x-axis always time component and y-axis always displacement component. Even if you have any detail further than this, then you can see the previous video so that you can understand the things properly. This is a displacement time graph, and here the slope of the graph will be like little bit upward. So this is the behavior of an displacement time graph. Okay. So in this displacement time graph, the slope is little bit upward. So we can say that the slope of an displacement time graph, slope of an displacement time graph is nothing but slope of an displacement time graph is nothing but it is an increases. Since the slope is increases, condition number 1, the slope is increases, so obviously we can say its velocity is also increases. Its velocity also increases. Its velocity increases. And then the next thing, motion is an accelerated motion. Motion is an curve is said to be increasing only. Curve is said to be increases. Curve is said to be increases. Similarly, you can draw the graph for the next segment, that is velocity time graph. You can draw the graph for the velocity time graph. So in this velocity time graph, you have to represent x and y axis. This is the time component and this is the velocity component. So you can able to understand velocity component if the graph will be increases, like in this style. If the graph is increases, you can say slope of velocity time graph. If the slope of velocity time graph, then it is said to be as increases. It is said to be as increases and its displacement will be increases. It is said to be as increases. It is said to be as increases. What is increases here? Since it is a velocity time graph, so I can say acceleration is increases. Acceleration is increases. And accelerated is increases. And at the same time, the curve is also increases. At the same time, curve is also increases. Very next thing, we are going to talk about the same graph. That is nothing but the same style curve graph only, but here the things will change like this. So now the curve is in decreasing style. So x and y axis, here time section will be there, here displacement section will be there. So in this time and displacement section, we have to understand about the downward graph. Condition number 1, slope of displacement time graph. What is the slope of a displacement time graph? Condition number 1, it is downwards with the passage of time. It is downward with the passage of time. Condition number 1. It is downward with the passage of time. Point number 2, its slope is decreases. So slope is decreases. Sir, how can we define it as the slope is decreases? You can define the slope like this. You can define the slope like this. Even you can define the slope in this style. So the slope is decreases. Okay. Next, the slope is decreases and followed by it is an decelerated motion. So velocity is also, obviously velocity is also decreases. Velocity decreases. Next, you can draw the same graph for the velocity time. So this is the velocity time graph, and in this velocity time graph, the slope is decreases like this. So the slope of velocity time, in which the condition number 2, it is decreases with the passage of time. Same thing you have to represent, but in the same manner, in a different style, because it is a velocity time graph. Passage of time. Then the next point, slope is decreases. Slope is decreases, or slope you can say decreases, and obviously it is a decelerated motion. It is an decelerated motion. So we can quickly review the next point, that is all the points which we have discussed today. Displacement time graph, it is a straight line. So slope is a displacement straight line, it is constant velocity. Then velocity time graph, it is a constant acceleration. Curve is an increasing curve, passage of time it is increases. So that means velocity increases. Velocity time graph, it is an acceleration is increases. Same manner, here slope of a displacement time graph is decreases with the passage of time. So velocity decreases. Obviously in velocity time graph, it is a decelerated motion. It is decreases with the passage of time. I hope you will be very clear for the graphical section of the class. Hope you will not forget to subscribe, like and comment on the video. Thank you very much for the today's session.